Good evening, good afternoon, good morning. This is Gary Stafford. I'm a solution architect at AWS. I've been working with the Ahana team for quite a while now and have been using their products and testing their products on the AWS platform. So I'm going to start off by talking about a few of the AWS constructs as it relates to the Ahana Cloud product, and then Dipti will talk more specifically about Ahana Cloud, and we'll finish up with a demo and Q&A. So to start off with, I'm going to talk about Amazon Elastic Kubernetes Service, or Amazon EKS. Amazon EKS is the service in the customer account in which Ahana Cloud is deployed into. So to give you a little more information on Amazon EKS is runs upstream Kubernetes, so nothing special about it. We use the Kubernetes stream. It is certified Kubernetes conformant. Currently, EKS offers 4 versions: 1.15, 1.6, 1.7, and 1.8. And 1.8 is our default version. So if you decide to spin up a new Kubernetes EKS cluster today on Amazon, you'll get 1.18, which is also the version that Ahana Cloud is running on. And then AWS supports each minor version, 1.5, 1.6, 1.7, 1.8, for approximately 9 months after its first release. So you have time to upgrade. And you are able to automatically upgrade through the console or through the CLI when a new version becomes available. But if you're using Ahana Cloud, they'll take care of all that for you, so you don't have to worry about it. A little background on EKS. Again, if you're using Ahana Cloud takes care of all this for you. They set up EKS and they install Ahana Cloud and all the software in your account as a customer. But just to give you some background on EKS to understand what's running under the hood. EKS runs in 2 VPCs, or virtual private clouds, on AWS, which are 2 different blocks of private IP addresses that gives you the ability to control your network access and egress and your security around the resources that are deployed within those VPCs. EKS is a fully managed service, which means that one of the VPCs is controlled by AWS. In this case, with Kubernetes, if you're familiar with Kubernetes, that would be the control plane. So AWS fully manages a control plane for you, and you're able to control the number of worker nodes which are deployed to the data plane. And that can grow or shrink depending on your need, and you can determine the type of EC2 instances that you would use depending on the particular applications that you're running within the compute plane. A typical EKS deployment of the control plane, I have a quick diagram here that shows you a single VPC, and it's deployed across 3 availability zones for high availability. There's a network load balancer in front of it to distribute traffic evenly across the availability zones. So what does Amazon EKS give you as a fully managed service? So Amazon automatically manages the availability and the scalabilities of the Kubernetes control plane. It's responsible for stopping and starting the containers that are running on the nodes. It schedules containers on the VMs, and when I say VM, those are EC2 instances. In AWS terms, those are the worker nodes which are running the containers in the pods. It's responsible for storing the cluster data, and it will automatically detect and replace unhealthy nodes in the EKS cluster. So you get all that out of the box with EKS. You can provision your own EKS clusters either through the CLI, the SDK, or directly through the AWS console. You see a few quick screen grabs here of setting it up. It's pretty easy. And there's several different configurations, whether you want to create a public-facing cluster, a public-private cluster, or a completely private cluster for internal access to your teams. Again, typical deployment of Amazon EKS. In this example, we have 1 VPC, or virtual private cloud, and we have nodes distributed across 3 availability zones, and those nodes are in private subnets. And then we have a bastion host and a net gateway to provide ingress and egress into the worker nodes to deploy resources and for those nodes to be able to download and update. And then you can see on the far right-hand side, Amazon EKS, and that would be the managed control plane, which controls the deployment and the ongoing operation of the data plane. So that was a lot about Amazon EKS. And again, the reason we're talking about EKS is Amazon EKS is one of the primary services that Ahana Cloud leverages in order to securely deploy their solution into your environment. So let me talk a little bit more specifically about Ahana Cloud and what Ahana Cloud terms their In-VPC deployment method. So typically with deployments to AWS, there's two types. So if you're working with a partner that provides a solution, generally it's a SaaS solution, which means you log into the partner's interface and you perform your operations through that interface. The other option is a DIY method where you deploy the resources into your own account and fully manage it yourself. So talk about some of the advantages and disadvantages of each. With a SaaS provider, it's fully managed, right? So you're not doing all the hard work, you're not doing all the heavy lifting. The SaaS provider provides you with an interface into the service which you've purchased or licensed, and you're able to use that without managing those resources yourself. Now, when we talk about analytics services or services that provide access to your data, oftentimes with a SaaS provider, you lose some control over your data. Oftentimes, you're caching a local copy of your data on the SaaS provider's interface or in their account, which is running on AWS. So there's some duplicity there. There's some duplication of data, and you do lose some control, especially if that data contains PII information, credit card information, or any type of confidential information. You have to make sure that the SaaS provider is securely storing your data. With the do-it-yourself method, the disadvantage can be you have to build it, you have to manage it, you have to patch it, you have to take care of all the care and feeding of those resources. When we talk about data and data analytics, the advantage though is that you retain full control of your data. So the data remains within your account. It's not being copied outside of your account or to other accounts, even within the AWS platform. With Ahana Cloud, and Dipti is going to talk more specifically about exactly how Ahana Cloud works. With Ahana Cloud, you really get the best of both of those. So you get a fully managed service and analytics as a service, but it's fully managed within the customer's account, so within your account. So by fully managing it within your account, we'll talk exactly how they do that and how they do it in a very secure method. You're able to retain full control over your data, so you're not copying your data out of your AWS environment to another environment in order to perform analytics at it. But at the same time, using Ahana Cloud is able to create a very scalable, highly performant, in this case, Presto environment for you to perform data analytics in without you moving your data to Ahana Cloud. So how do they do that? How do they securely have control over your account and deploy resources to Amazon EKS within your account? So when you first get started with Ahana Cloud walks you through setting up some roles within your account. You set up a secure role for Ahana Cloud, and you create a trusted relationship between your account, the specific account in which Ahana Cloud is going to be installed, and a specific account which Ahana Cloud, the Ahana owns. And that uses something called the Security Token Service, or STS, and it provides temporary limited privilege credentials to Ahana. And we also use an external ID, which is an added security feature for programmatic access to AWS, just to ensure that we're as secure as possible when Ahana Cloud connects to your account. And then that session is limited, so those temporary tokens expire, and the default is 1 hour, so there's not a constant connection to your account. If Ahana Cloud needs to reconnect, they get a new set of credentials, so those credentials are not long-lived if for any reason they're compromised. You set up a role, so if you're familiar with AWS, with users and groups and roles and policies, you set up a role specifically for Ahana and Ahana Cloud to be deployed to your account. You create a very explicit trust relationship between the Ahana account and your account, and including that external ID, which is an added security benefit. And you give Ahana Cloud very specific permissions to specific services within your AWS account. Certificate Manager, CloudFormation, EC2 instances, those are the worker nodes in your ECS cluster or EKS cluster. give them permission to EKS, Lambda, and S3, but very explicit permissions. You're able to review that policy ahead of time with your security team, make sure that it meets all your requirements, and then you install it. And only when you install it and you enable it and turn it on, will Ahana Cloud then have access to your account to explicitly deploy and manage specific assets within Amazon EKS. And the end result of that is a series of CloudFormation scripts. So you can see here, and we'll show this in the demo later, I have a development stack, an EKS stack, an Ahana Cloud Presto cluster installed, one in development with a single worker node, and one for production with 3 worker nodes. And you can see here that the CloudFormation stacks have been deployed. Those were deployed by Ahana through Ahana Cloud. I didn't have to do any of the work. And the end result of that is a single EKS cluster with all of the proper permission, security, and networking, logging all enabled. You have full access to that cluster. You have full access to all of the logs. You can turn on things like additional VPC logs in order to see exactly what's going on. So there's no limitations there in regards to if you have AWS enabled or third-party observability tools or security tools, you're able to use all those security tools to monitor the activities that are going on within your EKS cluster on which Ahana Cloud is running. So I think that's it, Dipti, on my part. I'll turn it over to you.
Sorry about that, folks. Hi, everyone. Dipti Borkar here. Excited to be presenting with Gary and sharing a little bit more about Ahana Cloud for Presto. The co-founder and the chief product officer, and spent many years in the database and the analytics space. And it's exciting to get to take a very complicated space with distributed data systems like the Presto engine, which is a disaggregated engine, and make it simplified for all sizes of data platform teams, small teams, medium-sized teams, because the value of Presto and these engines is in the insights that you get from it. And so we want to simplify that entire deployment and management process for our users. So first thing is I will walk through a little bit of why we built this and what Ahana Cloud is and what it does, and then we'll move to the demos. So for those of you who may know Presto or may not know Presto, Presto is a disaggregated query engine. It comes out of the Hadoop ecosystem, which makes it a little bit complicated. It is a query engine that depends on other parts like a catalog, a data catalog, like Hive Metastore, and other pieces which don't come with the query engine itself. In addition to that, given that it came out of the Hadoop ecosystem, it's quite complex in the configuration properties, the node properties, the JVM properties, as well as the data catalog, and the data source properties that have to be configured. And there's probably 200, 300 plus properties that you might need to configure to get things right. And so with Ahana Cloud, you get all of this pre-set up, pre-integrated, easy to use. The steps that are included, first thing is signing up for Ahana, and that's at app.ahanacloud.signup. The next thing you do is, as Gary was talking about, we create an Ahana compute plane. The compute plane is running in your account, and this means that we take the query engine, we take Presto, and we bring that compute to your data. We bring it to your data in your AWS account, and so it's built to be highly secure. And then finally, once your compute plane is created, which is a one-time operation, you can create any number of Presto clusters. This allows you to have multiple different clusters for different teams, different workloads, and so on. All of this running cloud native on AWS, built with the best of AWS underneath it. And so what Ahana Cloud gives you is Presto as a mini cloud data warehouse, but in an open disaggregated stack, because you can then use open formats like ORC and Parquet that Presto is optimized for. It also supports a range of other formats like JSON, CSV, text, and others. We use an In-VPC deployment, which means we take the compute and bring it into your account in a VPC that's managed by Ahana, and this makes it extremely secure. It comes with a built-in metadata catalog as well as a data lake integration with S3 and Apache Superset, which is a pretty powerful BI dashboarding tool that gives admins visibility and access to clusters to test things out. In addition, you get full lifecycle management. So starting, stopping, restarting, terminating clusters with click button access. And I'll show you what that looks like in just a minute. And this allows for easy cost savings, as well as easy starts, because all of the configuration for these clusters is maintained. And with a click of a button, you have all your catalogs, all the data sources that might be attached to Presto available to you once it's provisioned. It is bring your own data source, and most common data sources that we see are S3 data lakes. Multiple buckets can get integrated with Presto and with the Ahana Cloud. RDS MySQL and RDS Postgres tend to also be popular. There are a lot of users who want to have a lot of data in S3 in their data lake, but they want to do a join across S3 and MySQL or S3 and Postgres. And that is something that Presto allows you to do, is federate across different data sources and gives you the ability to join and find correlation across them. And we'll have a demo later on, which actually will show you how that works, as well as Elasticsearch and Redshift. All of this is running on EKS, but in some ways that's just a detail, because underneath the covers, you don't have to worry about what is happening, what are the resources that Ahana Cloud is deployed on. All of it is automated using CloudFormation, as well as using our Ahana console control plane. So let's take a look at the high-level architecture next. So the Ahana console manages the cluster orchestration, creating of clusters, terminating clusters, restarts, adding data sources, things like that. It comes with consolidated logging, and we'll take a look at how that works, both with server logs, Presto query logs, superset logs, etc. Gives you added security to your clusters, and finally billing. It's Ahana Cloud is integrated with with the marketplace, and so you have it's the pay-as-you-go model, and I'll talk a little bit about that as well. So once you create your compute plane, the Ahana compute plane in your account, you're ready to create your Presto clusters, and these then connect with a range of different data sources that you might want access to. So, from a cost perspective, big data can be prohibitive. A lot of users, cost is a pretty important consideration. And so with Ahana, it is a pay-as-you-go model. There is a fixed base cost that you pay just for your resources for the compute plane, which is less than $5 a day, just for EKS and the load balancers, things like that we use to deploy the stack all the way from networking down. And in addition to that, HANA cost itself is on a per instance basis, and so you only pay for what you use. So with that, let's take a look at the service itself. So first thing is when you register with Ahana Cloud, you do a setup. You set up your account, and this is something that Gary was mentioning. You use the policy that it needs to provision these resources in your account. So you have full access to the policy, and you see that almost all of these are conditional, which means that it only can manipulate resources that are tagged with Ahana. And this is obviously to make it extremely secure, so that while we are in your account, it's only limited to resources that are specifically tagged. You set up cross-account access. The product itself has a nice step-by-step instruction here, and you give back the role that you want Ahana to use as the master role to provision these resources into your account. You pick a region and this would be where your data sources are located, because you want your compute and your data to be co-located together. You pick a couple of availability zones and AZs. These are you pick a minimum of 2, because by default EKS is spread across availability zones, and you get the high availability built into the system. Here you pick a domain name, which would be company name, project name, and that is important because it essentially we create endpoints for all your clusters, so that the networking piece is taken care of for you as well. Once your compute plane is created, you come to this screen, and at this point you can create clusters, you can add data sources. here you see that I have a couple of clusters already created, and and let's take a look at what's in here. So let's take a look at the telemetry cluster. So this Presto cluster, you see it's a 2-node cluster. It's very easy to update, resize, downsize the cluster. You pick an instance type that it's running on, and it's pre-integrated with S3. So that means if you run a create table statement on Presto, you've selected Hive Metastore as your catalog, you get a storage that's pre-attached, and so all your data for temporary tables, things like that, they are all, you don't have to manage this on your own. It essentially gets converted into a mini database where you can create tables and select on them and query them. You have cluster credentials. Your endpoints are all set up here, as you see here, and you can change your Presto cluster credentials. These credentials get used when you're using JDBC or superset connectivity. As you see here, you have the connection string that you could use for superset, and you can change your data sources. So here, this cluster doesn't seem like it's connected to any data sources. So let's go in and add in some. So here you see I have a few different data sources that I've defined. I have Aurora, which is getting quite popular these days, and AWS Glue instance, and Postgres. So let me select all these and modify the cluster, and now at this point the cluster gets restarted automatically, brings it back up. If you had Presto deployed on your own, you would have to create a catalog property file for each of these, tune it, add the configuration parameters, and then restart the entire cluster and manage it on your own. And so with Ahana Cloud, it simplifies a lot of that. So here you see that you have one of those clusters in pending state, and these are the different states that the particular cluster can be on. An inactive cluster is one that has no resources provisioned if it doesn't have an Ahana Hive Metastore connected to it. In this case, it's a stopped cluster. You see it's 2 nodes or 5 extra large, running a 2.4.2 version of PrestoDB. And let's go ahead and start it up. And so it'll automatically provision it. You see that now this is in a pending state. Our telemetry cluster is back up. And now it has all the data sources attached to it that we had added in. So it makes it extremely easy to manage multiple clusters, multiple deployments. You have typically you have workload-based deployments. You have an ad hoc querying cluster. You may have an ETL cluster. You may have a data discovery cluster, because the kind of queries, the SQL queries that are running on these might be different. And so you can isolate at the cluster level. Next, let's take a look at what how do you create a cluster. So cluster creation is fairly easy. Let's call this a demo cluster. Presto by default has a coordinator and a set of workers. And so you have the flexibility to pick which instance type you want for your Presto coordinator. The coordinator typically is very important, and there's one coordinator. And so our recommendation usually is to pick a beefier instance for the Presto coordinator. You have a range of different instance types here, though. M5, C5s, R5s tend to be good fits for Presto because Presto is memory bound and compute bound most cases. And so these instance types, they're already we've shrunk the list of the best instance types for deployment here. So let's pick R5 to extra large for our coordinator. You can give it certain number of workers as well. And for the workers, let's pick M5s and go slightly smaller. And here you can decide if you want to bring your own data catalog or you want to use the Ahana Managed Hive Metastore. For those of you who may not be familiar with data lakes, a data catalog is very important because it is essentially the mapping between the database tables, columns, the schema, the structured schema, and the files that sit in S3 or HDFS or any kind of object store, cloud object store or HDFS system. And so that is how you know what tables exist in your S3, and it's the mapping between it. Glue and Hive Metastore are the two options that are available. If you have a Glue catalog, you can unselect this and you can go ahead and connect your Glue, and we'll take a look at data sources and catalogs in just a minute to see how you could do that. For this cluster, I'm going to go ahead and enable it, and you can also pick instance type for your Metastore. The advantage that you get with the Hive Metastore, Ahana Hive Metastore, is a few things. One is you get the ability to attach the query log for the cluster itself to the Hive Metastore, and so you can use Presto to actually query Presto's query log. And so the query log is available in S3, in an S3 data lake, and we can pre-attach this to your cluster so that as an admin, you have visibility into what's going on in the system, what queries are running, when did a query start, stop, who's running the queries. And so this gives you full administrative and admin audit capabilities on it. Let's pick a username and password here really quick. And then you can optionally give provide a role for this specific cluster. The reason this is important is AWS roles give you the ability to isolate different buckets. So, for example, if you have S3 buckets, you can have a bucket list with certain roles that are associated with it and that have access to that bucket. And so, if you want to isolate clusters so that they have access to only some set of S3 buckets, you could provide that role in here, and Ahana will use that role to create the cluster so that that is maintained, and only the users that have access to this cluster can access those buckets that you have defined. So for now, I'm going to go ahead and create this cluster, and so it comes up in pending state. It'll start to be provisioned, and typically takes anywhere from 2 minutes to 10 minutes, depending on the size of the cluster, depending on AWS, and so on. So let's take a look next at once this is set up, how do you actually query the cluster? Now that we have these clusters up, let's move to superset. And superset is, make sure I have the right URL here. So superset comes pre-integrated with the compute plane. This is running in your account on EKS. And the credentials are built into the Ahana credentials. So I had if I pick another cluster here, say, okay, it's maintaining my session. So once I'm logged in, I can go ahead and create data sources. So here you see that I have my test cluster set up where I've put in my URL. This is the URL that you would use, the connection string. And obviously you need to provide the username and password for it. And there's some configuration that's set up for secure access. So we only allow HTTP access across to all the clusters. And so the protocol, you specify the protocol here as HTTPS. Once you've selected and created this data source connection, you can then go ahead and query the cluster. So here you see that I have my Presto. I can select the Presto connection. Within that, you see a range of different schemas. First, let's take a look at the system schema. As I was talking about earlier, the system schema is where of the Hive Metastore is where we attach the query log if you have selected that option. And so there are two tables that are created here. There's a query event row and then a query event view. And so if we select that table, you get a preview of the table here. You will see that you'll see that the query log gives you the query ID, the query state, query time, who ran it. So root is we are creating these partitions. We are managing that for you, that data lake for you. And you see that I had run a couple of queries via superset here earlier. And so you have a visibility into everything that's going on that cluster and including the create table statements, and pretty much every system as well as user actions that are happening on the cluster. So let's actually create. Now let's go to another schema, which is the default schema, which you can use. So let's pick default, which is basically an empty schema within the Hive metastore. And here you can create tables, external tables, managed tables. So let's try to create a managed table here called user. It has a set of columns. And you notice here that it's in Parquet format and it has an external location. The advantage of Presto is that it queries in place. You don't have to ingest data. You don't have to move data anywhere. You point to the data and you can start querying. So I have a data set here, which is for these users. This is the location for it. And so let's go ahead and create this table. All right, and so now we go ahead and run the and so here you see that without any ingestion in place, I created an external table and I'm right away able to query this data from the external table that was created in the Hive metastore. So similar to this, you can connect any data sources. Ahana allows for a range of data sources to be connected. You see here that you could bring in your own Hive metastore. For Glue, all you need to do is provide a couple of different roles. The role that has access to your S3 buckets and a role that has access to the Glue catalog itself within the account. Glue is deployed on a per region basis. So if it's different from where your compute plane is defined, you can pick the region and set that up. RDS and MySQL, both MySQL and Postgres are very popular as well. These are the typical JDBC URLs with username and password that get set up. And so here you see that I have a range of different data sources. And so you could pick these data sources to create that connection with Superset, or just point to Presto and join across these tables. So with that, that was the overview for the demo for Ahana Cloud. What I want to do next is just talk a little bit more about what we saw in this demo, and then hand over to Gary for the next for the last step of the demo to see a join across multiple data sources. So here we see that what we did in this in the demo is we created a cluster. I think it was a 5 workers, 1 coordinator cluster with the Hive metastore. With a few selections that gets automatically created for you. You can scale up and scale down. You can add data sources to it with a few clicks. The auto start is taken care of for you. And then if you have a smaller cluster, you can scale that up. This is all done underneath the covers. There are node groups on EKS, and that node group is adding more instances and containers to it underneath the covers. But it's all automated and taken care of for you. And you can stop the cluster. When you stop the cluster, the configs are all maintained. And when you restart the cluster, it comes pre-connected, pre-attached with your data sources, as well as any other connections that you might have. So with that, Gary, let me hand over back to you. I'll stop sharing, and you can share your screen for the demo.
Thank you, Dipti. Let me share my screen. Can you see my screen okay?
Yep, we can see it.
Great. Let me just close this up. So as Dipti said, I'm going to show a very similar demo, but I'll show you how easy it is for Presto to federate queries across different data sources. So what I've done is I've set up, again, we talked about the role. So the only thing that I had to do as a customer of Ahana Cloud was create this role and give Ahana Cloud access to create clusters. I have 2 clusters running. Similar to Dipti's demo, I have a development cluster, which has a single master and a single worker, and they're smaller in scale. So if you're developing and testing your jobs, your Presto jobs, using a development cluster makes sense. I can spin it up when I need it, use smaller instances. I'm not worried about necessarily about how fast things execute. I'm able to develop my jobs, and then when I'm ready to execute those jobs at scale in production, I have a larger cluster here which uses 3 larger worker nodes. So I'm just going to run this off the development cluster just to show you how fast even that can be with Presto. For the demo, I've set up 3 data sources. Let me switch back here to the data sources and I'll show you. So I've created 3 data sources within the Ahana Cloud account that Presto is running. I've set up an RDS instance, so a Postgres RDS instance. Postgres is running on RDS, which is our managed database service, and there's a number of engines available. In this case, I have Postgres, and this is running in a separate VPC or virtual private cloud than Ahana Cloud. So I'm able to create a peering connection between those 2 VPCs, and from the Presto cluster, I'm able to securely access the database instance running in RDS. I also have a Redshift cluster running. Redshift is AWS's data warehouse solution, and this is in another account, in a separate account from the account that Presto is running in. So not only am I reaching to an external data source, this is actually a data source running in a different AWS account. And then finally, Dipti mentioned Hive as the metastore. I'm using AWS Glue, which is a Hive compatible metastore, which is fully managed by AWS. So again, 3 data sources: Postgres RDS, Redshift data warehouse, and AWS Glue. I've created those 3 data sources and I've attached those to both clusters. So I'll jump into Superset, and what I've done is I've taken, if anybody's familiar with Kaggle, I'm sure there's a lot of Kaggle users out there. There is the movie data set, which has 45,000 movies. It has 26 million ratings, so it has 26 million rows of data in the ratings table, and it has ratings from 270,000 users. So although it's not huge in terms of file size, it is a fairly large big data source, which is great for testing with the 26 million rows. You can see I'm back in Superset, just like Dipti demoed earlier. I've set up some data sources. So I have my Redshift, my Glue, and my RDS. Now you'll also notice I have direct connections to Redshift and RDS, so I'm not limited to only Presto. And as you're setting these up, sometimes it's great to be able to actually use Superset to connect directly and make sure that all of your networking, your security is in place, or to be able to troubleshoot if you're having any challenges communicating through Presto those data sources. So you're able to set up and maintain and manage multiple data sources. You're also able to export those to back those up. So I have a couple of saved queries. I've written 2 queries, and I'm going to demonstrate both of those. So I'll switch over to my SQL query editor. 2 queries. The first one is fairly simple. So you can see here that I have my movie ratings Glue data source. You'll recall that from when I was in the Ahana Cloud interface. And I'm simply doing a left join between the metadata table and the ratings table. And I have two input parameters, which I'm able to do through Superset. I'm actually able to, using Jinja templating, I'm able to inject parameters into my query in Superset, which is a great additional feature. And when I run this query, we can switch over quickly to the Presto interface. You'll see the query running here. So we'll see that query running again. I'm only running this on the single node cluster. So they finished relatively quickly. Again, that queried table that contains 27 million rows of data finished fairly quickly, and I got the result back here in Superset. So I've bucketed the results. I've looked at all of the movies across a certain period of time, and I've ranked those results and bucketed those, and I've calculated the average rating, the count of those ratings, and then the popularity, which is a secondary score in the database. And I was able to do that all in about 7 seconds. And again, that was only a single node cluster, so a little slower. And then for the second and the last query, in this case is a federated query. So I have 2 tables, the metadata table and the ratings table, which are coming from the Glue data source. And then I have the keywords table, which I've imported into my data warehouse. So I have the keywords table that exists in my data warehouse. And then in RDS, I've imported the credits table. So I've taken the data set from Kaggle, I've split the tables, and I've imported those tables into Glue, Redshift, and RDS. And again, with Glue, the underlying data for this resides in S3. So the metadata and the schema is in the Glue Hive compatible metastore, and the underlying data, which will be queried and displayed, is in Glue. And to Dipti's point, I'm not moving any of this data into Presto. Presto will go out and create a query and federate that query across these 3 data sources. So we can run that. And again, I'll switch over here to the Presto interface, and you can see that that query is running. And it should take fairly quick, again, just running on a single node for the demo. And that has finished. So it took about 13 seconds. 13 seconds on a 1-node worker node cluster, so a minimally sized dev cluster. And it performed a federated query across 3 different data sources, a Hive compatible metastore with the data in S3, a data warehouse in a totally separate AWS account, and then a Postgres database using RDS managed services, which is in a separate VPC. And that is my demo.